Hello everyone and welcome to my very first video. So today I want to be starting a series on how to deal with derivatives in calculus, right? Sort of an intro to calculus. I'm assuming maybe you already know the idea of a limit. That's what I'm hoping. But other than that, you don't even need to know the proper definition of a limit or anything like that to fully understand the derivative. Okay, so the problem that I see a lot of people face is that they get thrown all of these rules, like the product rule, the quotient rule, the chain rule, the difference quotient, all of this stuff, all these formulas, but they have no idea what they mean. And that's what's the point of learning the math if you're not going to know what the heck you're using, right? So the point of the videos I'm making is to not go through just what the formulas are. That's boring. I want to go into why. I want to prove why they work and give a conceptual and an intuitive understanding of what we're dealing with. So, starting with derivatives, you've probably seen this before. A function f of x, if you take the derivative, you get this whole thing. The limit as some number h approaches 0 of f of x plus h minus f of x all over h. Okay, so what the heck is this thing, right? This is called the difference quotient. It defines the derivative of any function that has a derivative. Okay, so let's just keep this on the board in the corner to think about. The best way to understand why something works is to think of it in the simplest case, all right? We know what f of x means. F of x just means y, all right? F of x just means y. So, if we have an equation like y equals x squared, I'm sure we're all familiar with this. Give a little coordinate plane. It's going to look something like that, right? That's our y equals x squared. Now, what we want in a derivative is to take a point and find the slope of the tangent line at that point. So for this, it would look something like that line, right? Where the slope of this line is going to be the value of the derivative at whatever our x value is. Okay, so let's get into it. Let's rebuild our x squared. This time, what we're going to do, instead of finding the slope at a single point, because what the heck does that mean, right? I'm assuming you don't know derivatives fully yet. You don't really know what that means. So we're going to take it back to something familiar. We're going to take just the slope of a line, right? Call it the slope. We're going to pretend that this intersects the origin. I might suck at drawing, but it's okay. The slope from, x equals 0 to, let's say, x equals 2, right? This point is going to be 2 comma 4, right? X squared, our x is 2, so x squared is 4. That's easy enough to understand. Now, we consider what the average slope from 0, 0 to 2, 4 is, okay? So, rise over run, our rise is 4 minus 0 is just 4. And then, again, 2 minus 0 is just 2. So the average slope is 4 over 2, which is just 2. Simple enough, right? Now, let's consider, instead of using 2, 4, we'll say this is 1, 1. All right? So 1, 1. 1 minus 0 is going to be the change in y. Over the change in x is again 1 minus 0. This time we got 1. Notice that's not the same number, right? So when we change where we're going to, we get a different average slope. Now, for a derivative, we want the slope at a single point, which means each of these times that we're drawing this line, we want from here to here to here is closer, here to here would be closer, and eventually you just get closer and closer until you're infinitely close between the 2 points that you're choosing, and then the difference is basically 0. If it basically is 0, in math terms we say it is 0, right? The limiting case, which means that if we have a difference between any point, right now we're choosing 0, 0, right? But if it's any point, then our point is x. And then our next point is going to be x plus h, right? So we have x, our first point is x, f of x. That's easy enough to understand, right? Wherever x is the y value, remember f of x is just y, f of x is going to be the y value, right? So when x is 1, y is 1. When x is 2, y is 4 for y equals x squared. F of x is just going to be the y value. Now here, we're choosing another point, call it f of x plus a bit, right? F of x plus some amount. We are going to call that amount h. So our next point is x plus h, and then the y value of that. Our input is x plus h, so our output is going to be f of x plus h, right? Ooh, uh-oh, whoa, looks like it's all connecting, right? Let's get into it. F of x plus h is going to be, doesn't necessarily need to be more, right? It's just the general idea of whatever f of x plus that little bit is. So the average slope between these 2 points is going to be the change in rise. So it's going to be y2 minus y1, which is f of x plus h minus f of x over the change in x, which is going to be x2 minus x1. We have x plus h minus x. So x plus h minus x. So x plus h minus x. But we have an x and we have a minus x. So those cancel very nicely. So the average slope from x f of x to x plus h f of x plus h is going to be this. But the problem is, that's not going to be our derivative just yet, right? Because that's the average slope between 2 points. We want the slope of 1 point. So what we do is our h is that little bit, right? Before we made it 2, then we made it 1, and we saw that it was closer and closer to the tangent line, which means we need to take the limit, right? We need it to get infinitely close, which means we're going to be looking at a limit, but we want the additional distance to be essentially 0, and h represents our additional distance. So we take the limit as h approaches 0, right? Don't think of it as f of x plus h. Think of it as f of x plus a little bit, right? It's a little bit over, and we want that little bit to be as small as possible in order to get the slope at a single point. And obviously, we can see that we've now derived the original definition, that difference quotient. This is where it comes from. It doesn't matter if you have y equals x squared, right? You don't need that. It could be sine x, right? Look something like that. It could be 2 to the x, right? Look like this. Every function that has a derivative, basically a function just needs to be continuous and not incredibly wonky like absolute value of x, where it has these sharp turns. As long as it's nice and continuous and smooth, it has a derivative, and therefore it will have an f of x plus a little bit minus f of x over that x plus a little bit minus x, giving us our difference quotient, which is why the derivative of f of x is equal to this. Thank you guys so much for watching.